Free radical injury. Definition: molecule with one or more unpaired electron in their outermost orbit. Free radical: it is a molecule with one or more unpaired electron in their outermost orbit. Molecule with one or more unpaired electron in their outermost orbit. Example: O2 minus, H2O2, OH minus, OONO minus. Example of free radicals: O2 minus, H2O2, OH minus, and OONO minus. O2 minus, H2O2, OH minus, and OONO minus. Most potent free radical is OH minus. OH minus is the most potent free radical. OH minus is the most potent free radical. Other free radicals are O2 minus, H2O2, and OONO. Most potent free radical is OH minus. Excess free radicals cause oxidative stress. Excess free radical cause oxidative stress. Aging, cancers, neurodegenerative disorders like Alzheimer's disease, reperfusion injury. Excess free radical causes oxidative stress. Aging, cancers, neurodegenerative diseases, and reperfusion injury. Aging, cancer, neurodegenerative disease like Alzheimer's disease, and reperfusion injury. Production of free radicals. O2 is converted to O2 minus. O2 minus is converted to H2O2 by superoxide dismutase. O2 is converted to O2 minus. O2 minus is converted to H2O2 by superoxide dismutase. Okay, H2O2 is converted to OH minus, and here Fe2 plus is oxidized to Fe3 plus. This is known as Fenton's reaction. Production of free radical O2 becomes O2 minus. Via superoxide dismutase it becomes H2O2, and this becomes OH minus, which is the most potent free radical. And here Fe2 plus is converted to Fe3 plus. This is known as Penton's reaction. O2 to O2 minus, O2 minus to H2O2 via superoxide dismutase. H2O2 is converted to OH minus, which is the most potent free radical. Iron and copper proteins are transferrin, ferritin, and ceruloplasmin. Iron and copper proteins are transferrin, ferritin, and ceruloplasmin. Transferrin, ferritin, and ceruloplasmin, these are the proteins of iron and copper. Hence, always bound and cannot always produce free radical. Iron and copper proteins are transferrin, ferritin, and ceruloplasmin. Hence, they are always bound and cannot always produce free radical. Enzymes leading to the free radical production are NADPH oxidase, xanthine oxidase, and superoxide dismutase. The enzymes that lead to free radical production are NADPH oxidase, xanthine oxidase, and superoxide dismutase. They cause injury by oxidative modification of protein, damage to DNA, and lipid peroxidation of membranes. प्रोटीन्स का ऑक्सीडेटिव मॉडिफिकेशन होता है, डीएनए डैमेज होता है, और मेम्ब्रेन्स का लिपिड पर ऑक्सीडेशन होता है. प्रोटीन्स का ऑक्सीडेटिव डैमेज होगा, प्रोटीन्स का ऑक्सीडेटिव मॉडिफिकेशन होता है, डीएनए डैमेज होता है, और मेम्ब्रेन का लिपिड पर ऑक्सीडेशन होता है. They cause injury by oxidative modification of proteins, damage to DNA, and lipid peroxidation of membrane. प्रोटीन्स का ऑक्सीडेटिव मॉडिफिकेशन होता है, डीएनए डैमेज होता है, और मेम्ब्रेन का लिपिड peroxidation होता है. प्रोटीन का ऑक्सीडेटिव मॉडिफिकेशन होता है, डीएनए डैमेज होता है, और मेम्ब्रेन का लिपिड peroxidation होता है. Let's see antioxidants. Enzymatic antioxidants are superoxidase, superoxide dismutase, catalase, and glutathione peroxidase. Enzymatic antioxidants are catalase, glutathione peroxidase, and superoxide dismutase. superoxide dismutase, catalase, and glutathione peroxidase are the enzymatic antioxidants. The non-enzymatic antioxidants are vitamin E, A, C. Vitamin A, not an antioxidant in aqueous humor of eye. Vitamin A is not an antioxidant in the aqueous humor of eye. Then other non-enzymatic antioxidants are selenium, manganese, and zinc. Vitamin ACE, that is vitamin ACE, ACE, and selenium, manganese, and zinc. These are antioxidants, non-enzymatic antioxidants. Superoxide dismutase, it inactivates the superoxide free radicals. Superoxide dismutase inactivates the superoxide free radicals. See, there are different forms of superoxide dismutase. ठीक है, साइटोप्लाज्म में SO_D1 is formed. साइटोप्लाज्म में superoxide dismutase is formed. माइटोकॉन्ड्रिया में superoxide dismutase 2 is formed. साइटोप्लाज्म में SO_D1 और माइटोकॉन्ड्रिया में SO_D2. SO_D1 is copper zinc superoxide dismutase and SO_D2 is manganese superoxide dismutase. ठीक है, तो साइटोप्लाज्म सी से होता है, कॉपर भी सी से होता है. साइटोप्लाज्म सी से होता है, कॉपर भी सी से होता है. ठीक है, तो कॉपर जिंक सुपरऑक्साइड डिस्म्यूटेज साइटोप्लाज्म में होता है और मैंगनीज सुपरऑक्साइड डिस्म्यूटेज इज देयर इन द माइटोकॉन्ड्रिया. Brain is protected from the free radical injury by SOD1. Brain is protected from the free radical by SOD1. Clinicopathological correlation. Mutation of SOD1 leads to amyotrophic lateral sclerosis. Mutation of superoxide dismutase 1 leads to amyotrophic lateral sclerosis. Mutation of SOD1 leads to amyotrophic lateral sclerosis. Mutation of SOD1. SOD1 ब्रेन को प्रोटेक्ट करता है फ्री रेडिकल इंजरी से, तो इसके म्यूटेशन के कारण amyotrophic lateral sclerosis होता है. Catalase. Catalase inactivates H2O2 present in and is present in the peroxisome. Catalase H2O2 को inactivate करता है and present in peroxisome. Catalase inactivates H2O2 and present in the peroxisome. Glutathione peroxidase. Glutathione peroxidase H2O2 और OH- दोनों को inactivate करता है. Glutathione peroxidase H2O2 और OH- दोनों को inactivate करता है and it is present in both cytoplasm and mitochondria. ठीक है, ग्लूटाथायोन पेरोक्सिडेज साइटोप्लाज्म माइटोकॉन्ड्रिया दोनों में होता है. कैटलेज जो है वो H2O2 को इनएक्टिवेट करता है, वो पेरोक्सिसोम में प्रेजेंट होता है. और ग्लूटाथायोन पेरोक्सिडेज H2O2 OH- दोनों को इनएक्टिवेट करता है एंड ग्लूटाथायोन पेरोक्सिडेज इज प्रेजेंट इन बोथ साइटोप्लाज्म एंड माइटोकॉन्ड्रिया. Intracytoplasmic ratio of oxidized glutathione to reduced glutathione is an important indicator of oxidative stress. The intracytoplasmic ratio of oxidized glutathione to reduced glutathione is an important indicator of oxidative state of a cell. Intracytoplasmic rate, intracytoplasmic ratio of reduced, intracytoplasmic ratio of oxidized glutathione to reduced glutathione is an important indicator of oxidative state of a cell. Intracytoplasmic ratio of the oxidized glutathione to reduced glutathione is an important indicator of the oxidative state of a cell. The intracytoplasmic ratio of oxidized glutathione to reduced glutathione is an important indicator of oxidative state of a cell. The intracytoplasmic ratio of the oxidized glutathione to reduced glutathione is an important indicator of the oxidative state of the cell.